What do? We try to support all the challenges that we have today in the world, which is a triple challenge crisis. Is the one related to climate change, of course, is the one related to supporting the green agenda, but also trying to have all the means that we can offer in terms of supporting means to tackle everything that's related to extreme weather events, which are increasing these days, to biodiversity, to better sustainability on our Earth, natural resources management and resilience. And of course, at the Ministerial, we have a package of programs which is really comprehensive, which is really coherent, not just in terms of providing continuity of the missions that we have up and running in every domain like science and also Copernicus, but it's also a package that provides for innovation, for science excellence, for a valorization of these existing available data sets that we have. And it's a package that, of course, supports all the priorities, the objectives of ESA, which are looking at protecting our Earth, but also supporting the commercial competitiveness of our companies. Today, I think we live a moment of uncertainty in terms of geopolitical context. It's a moment of war. It's a moment also of big changes in terms of the dynamics that we've been living, in terms of the collaboration that we have very strong with some international partners in the space domain. We've been working ages with partners like the US, Japan, Russia, and today we see a changing context, also due to the war, but generally due to the geopolitical context. And this is impacting, but it's also giving a strong opportunity to Europe to lead in terms of autonomy, to lead in terms of strategic autonomy. And that's really what we have today in Earth observation. We have collectively in Europe been able to build programs like Copernicus, which are a common owned infrastructure in terms of supporting environment and climate. We also have meteorological programs which are really innovative, and we have a lot of excellence in science mission that do support our sustainability challenges. So I think today, not just in terms of wealth of infrastructure, we have 16 satellites in operation at ESA, we have 40 satellites in the making. We have to guarantee this longer term continuity of this leadership in Europe, which is not just a leadership in terms of an industrial capability one, it's not just a leadership in terms of having the biggest wealth of data to support climate and environment. We have 300 terabytes per day of Copernicus data, but it's also political leadership in terms of strategic autonomy in this domain. It's very important to go beyond the punctual every 3 years decision-making process of the ministerial, to have really a strategic view of the evolution of the agency, the role that it has in the context and in the ecosystem in Europe and worldwide. And today we have 5 principles of this strategy. Many of those connect to the Earth observation programs that I have the privilege to lead, not just the one protecting our Earth. Of course, that's exactly what our programs do in terms of protecting, managing better natural resources, and also forecasting and seeing how the Earth would evolve if you better use the capabilities to have predictive models and models that tell you about the future. But I think also some of other goals are extremely relevant for the programs we propose to the ministerial. Just to make an example, we support the competitiveness of European industry. And this is really what we do also with the Earth observation programs at ESA, because not only we support the capacity of our industry to increase the TRL technology competence. We support the industries with demonstration projects to enter new markets in outside Europe, in Latin America, in Africa, and Southeast Asia. And the value-added sector today, it's a huge one, for example, in Earth observation. It has a trend of increase of about 10 to 12% per year. And of course, the support to the competitiveness, which is a general ESA objective, is very well reflected into what we do and what we propose. If you switch off the satellites today, you won't have the meteorological forecasting that you need to know if you can go in your boat and go on holiday, but even if you can land somewhere, or if you can better predict hurricanes. But also, it has a very direct impact on our daily life in terms of being able to monitor much better with more precision and more repetitivity the air that we breathe. Just as an example, we have launched 2 satellites this summer with Copernicus instruments on board, but also with the EUMETSAT. And those instruments on board, those mission METOP second generation, and basically we have MTGS with a sounder, have also a Copernicus instrument on board that tell us every hour the air quality of the air that we breathe. And you know that today there are about 500,000 people that die every year due to the bad quality of the air we breathe. So it has a really direct relevance, everything we do, we measure and we build in terms of satellites for our daily life. And there are many more domains. Just to make another example, I think agriculture is a sector where we can really measure today, thank you to satellites, the decarbonization process, the implementation of the green agenda, the implementation of relevant legislation, because you can use less pesticides, but you can also measure that you're using less pesticides. And that's extremely relevant for us as citizens, for what we eat and what goes into the agriculture sector. Last but not least, I think we have seen, unfortunately, a lot of catastrophic events, natural disasters in the last years. Those are linked to fires, are linked to flooding, are linked to really the extreme weather events, which are the impact of the evolving meteorological context, but also related, for example, to sea level temperature increase or land increase of temperature in Europe. We've seen a lot of fires in Greece, in Portugal, in Spain. And a lot that you can do with satellites, it's really to not just monitor the impact of those events, look at the flood extent, look at the fire scars, but really try to have a mechanism to predict those events and supporting elements of information which are factual. Just as an example, you can have through satellites like SMOS, this is a Futurio satellite, you can have the hydrology of the terrain. So you can understand if there is already an hydrological situation that can be connected to a potential flooding. And this is exactly what happened in Valencia, for example, where the hydrology of the terrain well before the event was already saturated. You can also see if the temperature of the land is increasing. And thank you to variables and information that is connected, also thank you to new digital technologies like AI, you can potentially have indicators that can help you to predict fires on land. Well, the future of Earth observation has to be continuity in terms of science excellence, because we have a lot of scientific gaps that we need to make sure we will be able to measure through the future satellites. And that's really the core of what Futurio is proposing in terms of program also at the ministerial. In terms of mission, an hydrology mission like NGGM will help us to look at climate, ocean circulation, and really everything that's related also to the water management, better water management on our Earth. So we need science excellence to continue. We need operational mission continuity like Copernicus, because the users expect long-term data series in terms of consistency of those data, in terms of quality of those data, and reliable data in terms of data that come from similar instruments on a long term. We also need to make sure that we use at best all what we have in terms of wealth. Today, we have a lot of data available. It's really a golden mine, and we are trying to really integrate everything that can be offered by the digital domains in terms of machine learning, high computing capabilities, artificial intelligence, to use those data that we have available from the fantastic mission we have in terms of increased efficiency and speed of usage of those data. So if you can do a predictive model in 1 month, now you can do it in 2 days, and that's extremely relevant no matter if you monitor the evolution of the Mediterranean or the Arctic region.